Hi, welcome everyone to today's session. We have an amazing guest here today. We would need you to please share this link to others to also join the session, as we'll be having a very practical session today. Um, So kindly share this link to your colleagues, share it on your WhatsApp, on all social media platforms. We need more people joining this session. We need more people joining today's module. Kindly share this, share it. So we'll just wait backstage as more people join the chats or join the stream. All right, I can see more people joining. Share the link. Share the link. Give us a hi. Tell us what's up on the chat. Zikora, we can see you. Kingsley, um, kindly share this link on your WhatsApp status on any social media platform. We need everyone gaining from today's session. So today we have an amazing guest with us today. We have Ayomide Adebara, who is a blockchain engineer extraordinaire. Michael Nwogu, I can see you. Kingsley, I can see you. More people are joining. Welcome to the stream. I see you, Joseph Samuel. I see you. All right. Welcome everyone once again. Today is going to be our most practical session yet. We have an amazing guest with us today. His name is Ayomide Adebara. This is Ayo. I've known him for years. We've worked together at Web3 Bridge as classmates, and he was one of those very, very outstanding students who now is a very outstanding professional in his field. Today, we'll be talking about blockchain transactions, we're talking about token standards. These are the foundational principles about blockchain. So if you know this and you can use this in your everyday life, we can as much say that you are a pro. So I'm bringing Ayo here on stage. Ayo, how are you? How are you doing?
Hi. Okay, man. I'm good. It's great to see you.
Welcome, welcome, Ayo. So some of the things I will be talking about today: P2P transactions. What are P2P transactions? I use P2P a lot. In fact, it's a lifesaver once you travel outside of Nigeria. You can seamlessly transact with any kind of FX, any kind of foreign currency, and you get your money in seconds. Ayo is going to talk about that. Ayo is going to talk about transactions, analyze in depth what makes up a transaction, right? A blockchain transaction. We're going to talk about token standards, ERC 20, ERC 721. All the juicy stuff is what we have for you today. So, Hayo, I am going to leave it up to you. If you need anything from me, just let me know. I'm going backstage. All right.
Hi, everyone. Happy to have everyone on board with me today. And from as as you've heard from last section, obviously you've been able to grab a detailed understanding of how wallet works. And so we'll be building our knowledge today from where my colleague from last time stopped. And so to start, I would basically start by sharing my screen, and then we would basically officially kick off. So blockchain transactions and token standards. This is literally what we will be focusing on in today's discussion. So what then is the goal of this whole discussion we'll be having today? First of all, we will understand what a transaction structure is across different blockchains, basically. We would look at some blockchains, what makes up their transaction. Next, we would also talk about what UTXO is. I'm sure some of us must have heard UTXO, unspent transaction. What exactly is this model? What blockchains makes use of this model? Then next, we would move on to talking about account-based models. Then we would see the difference between the UTXO model, which is the unspent transaction model, and the account-based model. What blockchain use the account-based model? What blockchain use the UTXO? So you look forward to that as we proceed in today's class. The next thing we'll then talk about is executing and analyzing P2P transactions. What even are P2P transactions? I'm sure every one of us, if not every one of us, we must probably have heard peer-to-peer, one place or the other. But what exactly is it? Have you used it? Well, we will discuss this in today's class. We would also move on to talking about distinguishing between a major token standards. What are the major token standards? Now, for this particular one, we'll be focusing on solidity, for the token standards on solidity, and that is what we will then be talking about. So whatever token standards we'll be pushing out or discussing today, it will basically focus on EVM compatible blockchains, that Ethereum virtual machine compatible blockchain. So that is what we'll be focusing on. Next, we'll be talking about DeFi protocols and their mechanism. Now, notice that everything we've brought together, it's kind of a very bulky thing. But then let's start breaking each of it down. And trust me, at the end of this lecture, every one of us should literally understand the mechanism behind blockchain transaction and all of these token standards that we'll be looking forward to. So what exactly is the anatomy of a blockchain transaction? Now, when we talk about the anatomy of a blockchain transaction, what it means is we want to identify what a blockchain transaction is made of. Now, we could think of it in two different manners. We could think of it through the
Sorry,
basic
sorry,
component,
Aya.
that is,
Sorry to break you, Aya. Can we have these slides on like a slideshow format so it's more legible?
okay, okay,
Thanks.
okay,
Great, great. Thanks, man.
okay. So now, talking about the anatomy of the blockchain transaction. Now, for the blockchain transaction, like I made mention of it, we can think of it in two different patterns, whether as the basic components, what comprises of a transaction, and then we can think of it through the life cycle from the beginning of a transaction, what transparent, what goes through the life cycle of the transaction, how does it start and how does it end? These two things we are going to be looking at. And in fact, we'll be looking at the blockchain scan to basically analyze all of these from the blockchain scan. But first of all, let's talk about the basic components in a transaction. First of all, we have the input. The input basically identifies what exactly is being spent. That is, when you send a transaction, now we are going to use a very basic type of transaction in this case. Sending, let's say you think of USDT, USDC, a stable token. Let's think of a stable token. When you want to send a stable token, you have the input, then you have the output. That is, input is specifying and identifying what is being spent. Then the output is basically specifying where the value is going to. What is this value? We are talking about, in this case, we made mention of stable tokens. So we are talking about whether it's a USDT token or a USDC token. Then next is the digital signature. Now, what does digital signature mean? Digital signature is literally a way to sign a transaction. Now, it means it just feels like we are literally saying the same thing. I mean, you're sending a transaction, you have to sign it. So what does that signing mean? It means that for every single transaction that happens on a blockchain, it starts from somewhere, and that is an EOA. So for every EOA, like you've learned from last week's lecture, it comprises of two things. First is the private key and the public key. Now, the private key is what you use to sign the transaction. And so the private key is basically what allows you to send this transaction. And that's what creates the what? The digital signature. Now, the other component is the transaction fee. Now, the transaction fee is literally what you pay to the miners, the validators that add that transaction to the blockchain. Now, how can we demonstrate this? I'll stop sharing now so I can share my full screen for us to basically see what it looks like. Now, for this particular example, I'll be making use of the Etherscan. Now, notice that I did not open the link down because I literally want us to see how we can basically go and look at a particular transaction. So I'm going to use Etherscan for this case. Now, for Etherscan literally allows us to view transactions that happens on the blockchain. Now, unless as an individual, you are a node operator, that is, you want to run a full blockchain client on your system, then that means you need an external party for you to show you what's going on the blockchain. And that is where scans come in. And so for this one, we'll be using Etherscan, which is literally a scan that allows you to see transactions going on the Ethereum mainnet blockchain. And so what does it comprise? Now, we know the blockchain is made up of blocks that makes up a blockchain. And so each of these blocks, that is exactly where the transaction is. Now, you can see from this scan, we have latest blocks. Then we also have latest transactions. So we are going to click on the latest block, which is this, and then we are going to see what happened inside of it. Inside of it, we can see the status, the timestamp when it was proposed, and the transactions that happened on it. Now, what we are concerned on here is the transaction. So we are going to open this and look at it. There are about 240 transactions that happened on the chain. Now, notice something which we are going to definitely talk about on as we proceed. Notice that some of the transaction is showing red at the side, meaning what? Error in transaction. Now, the different transaction definitely could specify what the error is. It might not specify what the error is, especially when it's a transaction that has to do with a smart contract that probably comes with a custom error. But we will leave that for later. Rather, what we will focus on now is a transaction hash. Now, we are going to open one transaction. Now, this transaction is a transaction that was successful. And then we are going to see all of the components inside of this transaction that makes it a what? A transaction that is added to the block. Remember, we said transactions are added to block and blocks are added to previous block to form a blockchain. Now, these are the fundamentals you've learned from previous class. And now we are going deep into the transaction. So for every transaction, it has a transaction hash, as we can see. Then it has a status. Then it has the block. What exactly is the block? The block is the block number for which the transaction was added. And inside of this transaction, remember that inside of this block, we had about 240 transactions added to that block. Now, out of that 240 transactions, this is one transaction. And so it specifies the block it was added. The next thing it specifies is the timestamp. So from this timestamp, we can see it happened about 2 minutes ago. And you can see the date at which this transaction happened. Now, the other important part we want to then look at is the from, the to, the value, the transaction fee, and the gas. What exactly is the from? Now, if we go back to our slides, we have made mention that we have the input and the output. And we said the input is from where it is being spent, that is, who is sending that transaction. And that basically signifies the from. And in this case, as you can see, this person that sent the transaction is, he literally has an ENS name. That is, ENS is a service you buy, and that service allows you to, change your Ethereum address. You can basically either use your Ethereum address or you can use the ENS name and transact. You can basically use it to accept transaction. And in this case, the person did that. You get. Now, so this ENS titanbuilder.it sent this transaction. And what did he send? He sent the transaction to this address. And what's the name of that transaction? It says Lido Execution Layer Rewards Vault. From what we can see here, it looks like this transaction has to do with what? Interacting with a contract. Because it is probably sending from an address to a contract. But then, this too is literally the output where the transaction is being sent to. Now, the next thing we can see here is the value. The value is how much that was attached to the transaction. That is how much money was transferred from this from to the to. And then the transaction fee. So the transaction fee is literally the amount paid to the validators, the miners, those who add this transaction to the block. And so if you are a node validator, you get a transaction fee, and this transaction fee basically goes to you. And then the next one is the gas price. The gas price is literally the amount you pay that is calculated in it for the transaction. And that's literally what the gas price. And in this case, the person paid about 1.677 what? GUI. And if you multiply that by the amount you basically have for the current price of Ethereum, that's if you convert the GUI is a unit of Ether. So if you convert that value to ETH, you have about 0.00, as you can see here, in ETH. And then if you now convert that, you can then get the amount of transaction fee that was basically paid. And this literally is what comprises of a what? Of a transaction. So you see the transaction has the transaction hash, it has the block number, the timestamp, the from, the two, the value attached, in this case, it's ETH, and then the transaction fee. And that's basically what comprises of what? A transaction. Now, when this transaction is created, it is broadcasted, and then the miner picks it up. If it conforms with the consensus layer, it is added. If not, it is rejected. Moving on. Now, we've spoken about what the transaction looks like. Now, there are two different types of ways of what? Of sending based on certain blockchains. Now, we have the UTXO model and the what? The account-based model. So how does the UTXO model work? UTXO is basically unspent transaction output. How exactly does it work? It works by a situation whereby each transaction consumes existing UTXOs, and then it creates a new UTXO that can then be spent later. You can think of this as more like a physical cash. When you spend a bill, you basically get a change. So let's say you want to get something, you spend the money cash, and then you obviously you get your change from it, because it's the amount of money you send, you get the change. So it's more like you send and then you get, it is returned back to you based on your change. And that is how UTXO work. Examples of blockchains that use this, obviously everybody knows about Bitcoin. Bitcoin operates on the UTXO model. Also Cardano and the Litecoin. These blockchains literally operate on the UTXO model. And what are the advantages of this? It's easier parallel processing, transaction fee is easily predictable. All of this literally allows for an advantage over the account-based model. But then the account-based model, does it have more other advantages over this? Definitely. What then are the disadvantages of this? First, more complex smart contract implementation, stateless model limitations. And this is a very big problem that Ethereum faced. But then we would see that later in the future as we would proceed now. The account-based model. How does the account-based model work? It's literally similar to the bank account. It has a global tracking for all account balances. What does this mean? This means that for every single address on, now for this instance, you'll be using the Ethereum blockchain. On Ethereum blockchain, all of these addresses literally have a balance. How do I know this? Now let's go back to our scan. We are going to use our scan to explain this. Now let's go back. I'm going to try to get an Ethereum address, a random address. Now let's use this address. Now notice that for this address, like I made mention of, for all Ethereum address, they have what we call account balance. Now this account balance is part of the structure in the Ethereum client. And this account balance is what basically holds the balance of a particular address. So as we can see for this example, this has the ETH balance, and here's the value. So for all of the addresses, you can click on any other address. Let's click on this one. If you come to it, it has an account balance. So how then does this affect what we are talking about? So what we are talking about is all of these accounts have their account balances. So there's a global tracking of these account balances. So now when a particular account transfers from another account, what happens is that the account state changes, and then the amount transferred is then deducted from what? From that particular account, and it's then added to the other account. Blockchains that make use of this model, example of it is Ethereum, BNB, that's the Binance Smart Chain, Solana. Why would you want to, in fact, implement this kind of model? For imagine you are building a blockchain, for example. First is that it allows for simpler smart contract development. Now, when you are writing your solidity case for the EVM compatible chains from this example, like Ethereum, it's easier for you to actually get your account balance. Basically, for any address, it's easy for you to get it. And imagine you need an implementation whereby you just want to subtract from the account balance and transfer even from the account balance. It's literally easy for you to do that. It's also efficient for token transfers, basically. All of these are advantages. But what are the disadvantages? Obviously, lower privacy. Now, when I went to this Etherscan, imagine I knew the owner of this address. The owner of this address, I already know that he has this amount of ETH. So imagine Ukeme, for example, sent me ETH. Immediately he sends me the transaction hash. He doesn't even need to send me the transaction hash. Immediately he tells me, hey, I have sent you the ETH. I can just go and check the transaction hash, check the latest transaction, and basically I would pull up his address, because obviously for every transaction, now this is a transaction hash. For every transaction, there's a from and there's a to. So I'll just check the balance of the from, and it is open. I can see Ukeme's balance. And that's probably a disadvantage for some people. They definitely want to keep their privacy, basically. There are other disadvantages from the slide, but we are going to move on because we have so much to cover. UTXO versus account-based. This is the visualized comparison between two of them. So as we can see from this instance, we have the inputs of the UTXO and the transaction, and then we have the output of the UTXO and the transaction. And so it transfers 3 BTC to a particular address, and it accounts for the fees. And then what happens is that there's another UTXO transaction that returns the what? The change, the balance, and updates what? The balance of the person that transacted. So it's more like you sent money to this person. You obviously, imagine you have a 1,000 naira bill or a $1,000 bill. You gave the person the $1,000 bill, and you know what happens is that you are going to receive a change. If you imagine you need to receive a change, imagine you've got something worth probably $400 and your change is about $600. What happens is the person hands you over $600 in cash, meaning you no longer are in possession of the $1,000. Now you have a different bill in your hand. And that's literally how unspent transaction output works. So you sent everything, and then it returns what you have as balance to you, just like you would do in cash. But then in account-based model like on Ethereum, it's different. What it does is it just updates the balance. So instead, it deducts from it and it sends it more like a bank account does. So what a bank account does is, obviously, when you send money out of your bank account, it doesn't first of all update that, okay, your bank account is now zero, then I'll give you your change back. No, it doesn't do that. Instead, it literally just removes, that is, it deducts the amount you've transferred out, also deducts the gas fee included in the transaction, and then you have your balance. And that's literally the difference. So let's quickly go and see an example of a BTC scan. BTC scan. There are so many scans. You can check out so many scans. But I'm going to use this BTC scan, and then you are going to see what the transactions look like and what the unspent transactions basically look like. So I'm going to click on transaction. I'm going to click on this transaction and notice what happens here. So I'm going to try to open an address. Now, notice what is happening here. This is an unspent transaction. So I'm going to try to open it, and yeah, this is exactly how it works. So you have confirmed spent transaction. In this case, we have about 50 outputs, and then you have confirmed unspent transactions. In this case, you have 4 outputs. So it has to work in a mechanism whereby it's not like I'm giving you money and I'm receiving my change. And so until the whole transaction is completed, until the miner picks up the transaction, then your account balance is then updated to the exact account balance you have. This is exactly how it works when it comes to blockchains that use the UTXO models. Now, going back to our slide, the P2P transactions, sending and receiving. So when you talk about the P2P, what comes to your mind? Peer-to-peer. Now, peer-to-peer, as you would hear, is a model that allows you to send transactions between 2 individuals. So let's say I want to more like like Ukeme started at the beginning of this call when he made mention of peer-to-peer. He said, okay, I can go around in different locations in the world and imagine I have my token. Let's just keep using the example of a stable token, probably USDT or USDC. And then I want to convert my token to, a fiat currency. That is, probably you travel to a different country where the currency is probably USD or Canadian dollars or whatever. You can basically engage in P2P by sending your token to someone else and then the person pays you in fiat. It's as simple as that. It basically allows you to send. Now, a problem comes in. What kind of problem comes in? Why should I trust the person I'm trying to send my money to? Would it send me the money back? Now, this is where different people come up with building different models called escrow services. Now, escrow services is a well-known service where you are linked up with an individual willing to convert his token to a fiat. It's trying to convert its token currency to a fiat currency, and then you are linked to this individual. If you like the price the individual is trying to sell, you are linked to the person, and then the token is locked up until you confirm that the individual has received the token. So this
Sorry, sorry, Ayo. Sorry, I just want to add to what Ayo is saying. I'm so sorry for coming in here. I want to give you a simple example of what I use P2P to do every single day. So imagine they pay you salary in USDC or USDT, right? Or they just pay you $1,000, right? And you go to whatever like Nigerian app to exchange your money, they probably will have a fixed rate of like, okay, $1,000 is 1,500, and $1 is 1,500 naira, right? But if you actually earn in crypto and you want to do P2P, you can see different prices in any of those escrow services like Bybit or Binance or KuCoin or whatnot. You can see people selling their own for like 1.6. You see somebody selling their own $1 for like 1.7, right? So once you do a P2P exchange and you get your money, you most likely will make some profit. So it gives you an advantage in terms of like your conversion and your earning power rates. You get. So I'm just trying to add to what Ayo is already saying.
exactly, exactly. Now, while Lukemia have made mention, thank you so much, Lukemia. While Lukemia has made mention of the basic meaning, now I was going ahead to explain how the whole idea works. And it's as simple as that. It literally you sending your cryptocurrency to someone and the person paying you in fiat currency. Now, what mechanisms do these enterprises that makes use of escrow services use to do this? Basically, they lock up the token, and once you confirm that you have received the amount that you are meant to receive, then you release the token to the individual. Now, there are different services that offer this. Now, you go to centralized exchanges for this, whereby for the centralized exchange like Bybit, Binance, KuCoin, like he has made mention of, all of these exchanges allows for the P2P service, linking you with individuals. And if you appreciate the price the person has listed up, then you can basically send the transaction. Now, the most familiar P2Ps you would have been familiar with are the centralized P2P. Now, there are cases whereby P2P could even happen between two different individuals. Two different individuals. Now, when P2P happens between two different individuals, whereby you do not use a particular platform to operate this, what are some security practices you should understand? First of all, you want to verify the addresses. Now you understand that if you miss a particular character from the address you are sending to, you lose that particular amount, and the person you are trying to send to will definitely not get it. So you probably want to start with a little test of transaction, double check all of the transaction, and then if you are using hardware wallets, you can use that basically for large transactions. So it's important that you are careful when you are practicing P2P. But then if you are using more like a centralized exchange for those that basically, work and you get your cryptocurrency paid into your centralized exchange wallet, then it's easier for you to basically just go to the P2P platform and operate. Then you don't have to worry about verifying the address and all of that. All of that detail is handled by whatever service is providing the escrow service. The next is wallet addresses and QR codes. Now, when we talk about wallet addresses, you have learned that extensively in previous classes. So we would not even be going deep into it. But then, why did we put it here? We want to talk about it because of this other part and QR codes. Now, we understand that the wallet addresses literally is what you use to receive your cryptocurrencies. Yes, when you want to send a transaction, it's basically what, oh, I want to send you about 100 USDC. It's your wallet address you ask for. Now, it's also possible for you to use a QR code for it. Why? I'm going to be showing us an example of a simple wallet. Now, this is my testnet wallet, and I'm going to use it as an example for what we'll be talking about here. Now, for every wallet, based on the wallet provider, now, in this case, the kind of wallet I'm showing here is the MetaMask wallet. It's compatible for EVM chains, basically. You go to the account details, and this allows you to see a QR code that you can basically use to receive your fund instead of what? Sending or copying the wallet address. Now, what is the difference between the wallet address and this QR code? There's no difference. But the important thing is sometimes people make mistakes while copying the wallet address, and then using the QR code is basically easier to do. Transaction fees and confirmation. Now, transaction fees, like I've made mention in previous slides, literally is the way miners, validators are incentivized, because they are literally adding your transaction to the block, and they are literally running these clients on their, it could be they are renting a VPS or whatever platform, or even their local machine, they are running it. Now, we understand from previous classes that we have spoken about different blockchain and what kind of consensus mechanisms it makes use of. And so this consensus mechanism, like for example, Ethereum that moved from proof of work to proof of stake, literally the miners, the validators are staking an amount of ETH. So in this case, they are incentivized for their stake, basically ensuring that the network is stable. So these transaction fees are being paid to them. So the fees in the Bitcoin network rather is paid in Satoshi by byte. What does this mean? This means that for every transaction you send, the higher the byte, the higher the Satoshi that is being paid for it. So that means that whenever you send a transaction, if the transaction is high, the UTXO transaction is high, then the gas price also what? Also increases. So now, what about the Ethereum? For Ethereum, Ethereum makes use of this formula. It's so simple: gas price times the gas used. And that's exactly what is inside of this transaction. Let's go back to a particular transaction for us to look at how this is calculated. I'm just going to pick, let's pick this transaction. And so from this transaction, we can see the transaction fee. And now, if we go back to our slide, what is the calculation for the fee? It is gas price times what? Times the gas use. So if you come back to here, we have the what? The gas price times the what? The amount of what? Gas used. Now, in this, the amount of gas used is multiplied by this to get what? The transaction fee. And this transaction fee is literally what is then paid to the what? To the miner. So there are different ways to check the transaction fee. So it literally fluctuates based on new Ethereum improvement standard that was released. That's EIP 1559. So that is something you can go through at your own time later on to check out how the Ethereum price fee literally changes. Confirmation. Now, for new blocks, there is a confirmation. What is confirmation? What is finality? Now, whenever a transaction is being sent, we want to remember that all of these transactions form up to become a block, and then these blocks are added to form a blockchain. Now, these blockchains are being run by different nodes. Now, how do we know that, okay, a transaction that has been added has reached finality? It has reached finality when certain amount of blocks have been added to the block. And when certain amount of blocks have been added to the block, then we can say it has reached finality. Why are we even saying certain amount of blocks should be added to the block before it is reached, before finality is reached? We can say this because by the time certain amount of blocks are added to the block, then this certain amount of blocks that are added are replicated on all of the node providers. Then all of these node providers form together a consensus, and then it can then not be changed again. And then once it is not able to change again, then we can say that particular transaction has reached finality. So even though a transaction is successful, until certain amounts of blocks have been added to the block the transaction was found in, we cannot yet say it has reached what? It has reached finality. Now, for what we have here, recommended confirmation vary by network actually. For small BTC transaction, about 1 to 3 blocks, but for large BTC transaction, about 6+ blocks. So let's say the transaction happened on block 100, then we need to have more blocks added before we can then say it has reached finality. For Ethereum, we estimated about 12 to 24 blocks before we can then say the transaction has reached finality. Now, talking about transaction components, going deep down. Now, we know we have gone to look at all of these from where? From Etherscan. But what are some other things we need to talk about? First of all is the unique identifier, which is the transaction hash. What is the transaction hash? Now, when someone comes to you and you're like, okay, I've paid your salary. Now, let's use salary for this instance. I'm like, okay, you've paid my salary, but I have not seen the token in my wallet. What do you request for? You request for the transaction hash. So the transaction hash literally is the cryptographic hashed component that literally allows you to go through a transaction. So when the transaction hash is then sent to you, it literally gives you the opportunity to view the transaction. So this transaction hash is literally unique to other transaction hash. So let's go back to Etherscan and look at one. Now, here are latest transactions. And what you can see here is the transaction hash. Now, let's in fact open a block and then look at all of this. In this particular block, we have about 233 transactions and about 50 internal transactions. Now, as you can see, all of these are the transaction hash for the block. All of these are the transaction hash. So let's open this transaction hash. Let's just copy it. So imagine someone sends you the transaction hash for probably the amount of cryptocurrency you have sent to you. All you need to do is to get the transaction hash, go to a scan and paste it. Once you paste it, you literally have detail about that transaction. You see what the person sent to you, the value. You see if you confirm if it is the person he sent it, if the amount is correct. Now, in this particular case, this transaction is successful. So if the person sent the transaction and it is not successful, let's try to look for a transaction that is not successful in this case. Yeah. This is an example of a transaction that is not successful. It failed. Now, this particular transaction is an ERC20 token transfer error. Is an ERC20 token transfer transaction. And so, why exactly did this fail? It said one, in error encountered during contract execution out of gas. So in this particular case, there are different ways to, to track exactly where this error occurred. Because sometimes, even when it says out of gas, the error might not exactly be that the person does not have enough ETH to send that transaction. So there are different tools for you to actually track the exact point a transaction occurred. And due to the fact that this transaction occurred on a particular token, which in this case is USDT, a stable token, it is important that you go through the smart contract and then you see where exactly it happened or what exactly went wrong in this case. The nonce. So in Ethereum, the sequential counter for what? For each addresses. So why is the nonce important? Why is the nonce important? The nonce is important because, sorry. Okay. Okay. Why is the nonce important? The nonce is important because, okay, let me go back. Okay, yeah. The nonce is important because when a person sends a transaction, the person transaction might not have been added to the block. Now it is possible for the person to resend that transaction over and over. Now, when a person sends two transactions that has not been added to the block, now in a sense, now let's ignore the fact that we've heard about nonce. Let's think of the fact that there is no nonce. What exactly then happened? Which of these two transactions is being picked by the miner? The transaction will become confused. Now imagine two different miners now pick each of these transactions and add them to the block. In that case, a replay attack would have happened. But due to the fact that there is nonce, a nonce is the sequential counter for each transaction that happens for a particular address. And this nonce keep increasing. So if you add another transaction, the nonce increase. And so a particular transaction with a lower nonce needs to be added before the one with an higher nonce. Now we have gas price, gas limit, input and output data. All of these are literally things we have discussed about. But what exactly is input and output data? This especially works when we are talking about smart contract interactions. So for smart contract interactions, you have a function. Let's give example, the transfer function, or let's use the transfer from function that literally takes the input, where you are transferring to, who you are transferring to, and the amount you are transferring. Then it returns, you could return a Boolean to say, okay, the transaction was successful. So this is literally what is included in the input. Now, the Blockchain Explorer, we have been able to basically look at the Blockchain Explorer even before we got to this slide. And like I mentioned, there are different explorers. For example, this particular explorer I made mention of, the BTCScan, literally has for Ethereum too. So now I can come here and I can basically, no, let's come here. Let's look for a transaction, and then I can basically copy the transaction hash, then search for it on a different explorer. You definitely would find the transaction. And here's the transaction, as you can see. It includes all of what you can find here, basically the same thing. So if you are a node provider, you can basically create a scan by yourself. So it's nothing, you don't have to say, okay, I want to use this scan over another scan. You can, if you're a node provider, you can create a scan yourself, give people access to seeing what is literally on the blockchain. And that is literally what node scans are. Now, moving on to analyzing transaction on explorers, then debugging failed transactions. Now, this was exactly what I was talking about. How do you debug a failed transaction? First of all, there are different reasons for
Hi,
failed.
sorry, hi, because of time, I would like us to skip this part,
Okay,
the field transactions, and just go straight to token standards because we have 10 minutes, so we need some more minutes also
question.
um, for question and
Okay.
answers. And if it's possible, we can just create a very simple token, ERC20 token, just so people just see how tokens can actually be created in just a few lines of
Yes,
code.
yes, yes, yes. We can do that. We can do that. So we are literally moving on to the token standards. So now for token standards, we have the RC20, we have the RC721, and the RC1155. What exactly is the RC20? It's literally a fungible token standard in Ethereum. And there are certain functionalities this particular standard must have. Now, All of these token standards we have made mention of, ERC20, ERC721, and ERC1155. All of them are smart contracts. Now, for all of these smart contracts, they follow a standard. Now, what does following a standard mean? Following a standard means that all of these smart contracts, when you are creating for this standard, must have these particular functionalities. So these functionalities must be included when you are creating these tokens. And now for ERC20, which is a very popular token, ERC20 is what the USDC you're saying are. All of these are fungible tokens, and all of them are literally smart contracts. So what are the key functionalities that must be found in it? First of all is the total supply. It must have a circulating total supply. That is the total amount of that particular token. Next, you must be able to check the balance of an address. You must be able to transfer, approve, and also transfer from. Now, these are the important things in a standard ERC20 token. Now, for this, we also have the same case for the ERC721. Now, ERC721 is popularly known as the non-fungible token, which is NFT standard. It's the NFT standard. And for the NFT standard, here are the functionalities: the owner of, the balance of, the transfer from, the approve, and even the safe transfer from. So all of these are important functionalities that must be found in the ERC721. And lastly, we have the ERC1155. So the ERC1155 gives the opportunity to combine both fungible, non-fungible, and even semi-fungible. And what are some key features of it? First of all, you have opportunity to do what we call batch transfer, minting, burning, all of this efficiently. And we also have single contracts for multiple token types. So you can have a single contract that literally have multiple token types combined together. And obviously, it has certain functionalities for it to be a standard. What are the functionalities for this? Balance of batch, safe transfer from, safe batch transfer from. So all of these are literally the functionalities. And this is popular. It's when you are creating a gaming Web3 collection. So you could use this ERC1155 also for collectible sets, the metaverse items. All of these, you can basically use the ERC1155 for this. Now, this literally shows the difference between every single one of it. But because of our time, we are going to use a simple tool for this. So now, this simple tool we are going to use for this is literally what we call Remix. Now, there are different tools you can use to write a smart contract, but in our case, we will be using Remix for this. And so this is what the interface of Remix looks like. And so,
Hi, hi, it's me again. Please, can you please
okay,
zoom in, yeah, so it can be legible because it's very, very tiny. Yeah, one more, please. Yeah, good, good. Thank you.
yeah. So for this, I literally have a smart contract written here, but then I'm going to remove some things. Then it's going to give us the opportunity to talk about what we want to talk about in this case. Now, the smart contract I have here, it's literally a token smart contract. But then we will literally be starting from scratch to look at the functionalities we have spoken about in this case. And so here is what the smart contract looks like. Now, for an individual, you might be asking yourself, would I have to create all of these functionalities that has been listed in this slide for me to create my smart contract, my token smart contract? The answer to that is no. This is because there are organizations that have come together to literally create this standard. And an example of it is OpenZeppelin. So OpenZeppelin literally allows you to use standard that has already been created. So it's easy. You don't have to rewrite the whole code from scratch. And this is OpenZeppelin. So you can go to OpenZeppelin GitHub for you to see this. So for the Open Zeppelin, it's a library that comprises of different token standards. And in our case, we are going to look at the different token standards under tokens. You would see the different token standards we've spoken about. We have the ERC1155, ERC20, and the ERC721. These are the tokens we are talking about. Now, for the ERC20, this is what we imported in our contract. Now, notice that the ERC20 I'm opening here, I'm going to zoom it in so we can see it, clearly have all of these functionalities I spoke about: the total supply, the balance of, the transfer, and the allowance. And that is literally what we will be using in our smart contract. So for this smart contract, I'm going to take out this. The only example we'll be creating is the ERC20 example. ERC20. So now, for this ERC20, there are certain functionalities inside the ERC20 like the mint. And as short as these lines of code I have created, it's easy for you to create a token like that. That is, you import the library from Open Zeppelin, ERC20 in this case, and then you allow your contract to inherit the library. And then the next thing, you can do whatever you want to do. First of all, in this case, I called the mint function for it to mint to a particular address. In this case, this msg.sender is the caller, the creator of this particular contract. And in this case, it is me. So to run this, you can basically compile it, and you can basically what? You can deploy it, basically. So you can deploy this here. So you have it. You can use this and deploy it. It says EVM, please make sure the current network is with this, otherwise deployment will fail. So I'm going to leave that right now because of our time. So Remix sometimes have some issues when you're trying to deploy. So I'm not going to, go into that. But to write a simple token, this is literally all you need to do. About 10 lines of code, and you are literally done, because there are libraries that have written all of these down for you. So at this point, I would want us to take questions at this particular point so that we can literally complete our lecture.
Yeah, yeah. You can stop sharing your
Okay.
screen. Um, thank you, Ayo. Any questions? Any questions from anyone? Questions? Please put your questions in the chat. Questions, suggestions. I think almost everybody, maybe people are very confused because we have more DevOps engineers here. So I'm just going to, while we wait for questions, I'm just going to tell you why, as a node ops engineer, what Ayo is telling you is very, very important. Ayo just talked about miners, right? So these miners are actually the node operators. They are the ones who are actually operating the node or the machine that is doing the mining, right? So if you're a node operator, you need to understand what your node is actually doing. Do you get? You need to know how you even make profits by being a node operator. He talked about transaction fees, right? He talked about gas. He talked about block finality. I'm going to give you a simple example of block finality. I do a P2P transaction on Binance. Let's say I went to South Africa and I'm trying to get South African rand or something. I don't have South African rand with me, but I have some USDT. I can do a P2P transaction, right? And once I do a P2P transaction, you most likely see somewhere where they write 5/10 or 5/20, right? It's just, that's just telling you the amount of blocks that are being confirmed, right? So when it gets to 20/20 or whatever amount that the network needs for block finality, that's when you will now actually have your money inside of the wallet. Do you understand? Or something? Do you get? So these things are things that you would most likely be using every day as a node operator, because you can also be working for a company. There's a mistake here. You can also be working for a company who is doing NFT, right? You can be working for a company who is doing loans. They create loans or something. You can be working for another blockchain company who actually has their own ZK roll up or something. So if you don't understand the technology and how it works, how do you want to operate the node? Do you get? That is why some of you might think, oh, this is just boring. I don't need to understand this. I'm a DevOps guy. I just need to spin up nodes and that's all. It is way, way deeper than spinning up a node. You need to understand what is going on inside of the node, right? So I think we have questions. One question is saying, can you do a video of him creating a smart contract? Okay, that'll be a separate video. He needs a smart contract video and send the video to the group for us to rewatch. Okay, definitely we'll do that. Actually, there's this link I shared here. It's called Solidity by Example. You can actually see how to create smart contracts, from the easiest to creating a token, which is also very easy to. You can just go there, check the link. There are YouTube videos there you can also use, just in case IO doesn't have the time to make those videos for you. Akim Falade says, a great presentation by Ayo. Ayo, you deserve your accolades. You're a very good teacher. I see Larry Ada here. Larry Ada, my G, says, please, can you explain a little why gas fees are different from transaction fees? That's a good question. I know you mentioned something about gas fees determining the transaction fees. However, I don't fully get that. Ayo, the difference between
Okay.
um gas fees and
So
transaction fees. You can take that
So
quickly.
I believe what you wanted to say is transaction fee and gas prices. So gas prices, as you can see from the slide when I was talking about the calculation of how a particular transaction fee is being calculated, it's literally the gas price times the amount of gas used. So when a transaction is being sent, for every single moment on Ethereum, there is a specific gas price at that particular time. So the gas price at that particular time multiplied by the total amount of gas that was used for that transaction. Most times it is estimated amount of gas that is being used for the transaction times the current gas price is what makes up the transaction fee.
Okay, so are you saying that gas fees and transaction fees are actually the same thing?
So when you talk about gas fees, now you can think of it that okay, it's the same thing, but it's you then start
Yeah.
confusing yourself with gas fees and gas prices because these are completely two different things.
Okay, but the gas fees actually is the fee that would actually be paid to the miner
Exactly.
for doing the
Exactly.
transaction. Yeah. So yeah. Um, Akim Faladay says, please share the slides. We will do that in the WhatsApp group. If you are not a part of the community WhatsApp group, please indicate so we can send you the link. Akim Faladay still says, yes, I need clarification on gas transaction fees and gas fees. They're actually the same thing. So let's not confuse gas fees and gas price. These are two different things. Gas price is also determined by the congestion of the network, right? If you have a lot of people trying to do something on the network, like in Ethereum, the gas price would actually increase because it's not fixed. I like this. POP Huasao says, what controls block finality? Why different transactions have different checks passed? Ayo, can you take that?
So, like I made mention of, when you say finality, remember that the blockchain is being run by different node operators. Now, for these different node operators, why can we, how can we be sure that the total amount of blocks and transactions they have on their end is in consensus? That is, it's the same. At that particular point, you start thinking of finality. At what point can we say this transaction is completely successful and it cannot be reversed back or it cannot be reverted? Then at that point, we say the transaction has reached finality. So why the transaction has been successfully sent and it is confirmed that it is added to the block until certain amount of blocks have been added after that block, then we can say it has reached finality. So at that particular point, we can say the transaction, we should not think of it reverting again. We should not think of it changing states again. So that's literally what that has to do, or that's literally what finality has to do with, the transactions.
Yeah, so to add to that, it also kind of like has to do with like confirmations, right? So, um, as a node operator, you run a node. Other people are running nodes. They are all have to confirm your transaction, and I think you have several transactions that makes up a block, right? So we need to have a full block with different transactions being confirmed. Once they're confirmed, we've reached finality for that block, and then things that block, the details there cannot be reversed, right? It is immutable. Um, Larry says, "How do I become a node operator as a DevOps engineer? Is this something I can do with Docker?" Ha 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 ha. So that's the reason why we have this session, is because we have DevOps engineers who do not know blockchain, and we have blockchain guys who do not know any DevOps. Now, as a DevOps engineer, Docker is just a tool. You can use Docker for anything. Docker is not blockchain, right? You to become a node operator, you need to know how the blockchain works, right? So it is literally you handling a node on for a blockchain, right? Do you get? So, and you need to have some blockchain knowledge, know how to use wallets, know what ZK is, know what transactions are, know, just be a blockchain guy, right? If you're a blockchain guy, combine your blockchain or Web3 experience with your DevOps experience, and you are a node operator or a node ops engineer. But to be a node operator, you need to be running a node, right? Maybe Ethereum, Oliski, or Sepolia testnet, or get different kinds, or a Polkadot node, different kinds. So it's not Docker. Docker is just a tool. Um, how can I make money as a node ops engineer after spinning up a node? Okay, so actually, you need to have a lot of money to be a node ops engineer, like to be a node operator, not a node ops engineer. Because if you're a node ops engineer, you can work with any company, but you can work with any company and they pay you salary. But to make your own money as a node operator, you need to have some bucks, right? Because your machines run on very high intensive. Your node is going to run a very high intensive um, machine, right? You'll be running something that has like a 32 gig RAM, or a 2 terabytes of storage, or a clock speed, very high clock speed, that kind of thing, to do the transaction. So to make some money is like you're staking. We talked about staking initially. So you stake some money into that network, which is the node running in a machine, and that machine just keeps mining and making money for you. Yeah, so those transactions people do, the transaction fee or the gas fees goes to you as a node operator, right? I hope that answers that. Larry Ada says, gas price times gas amount equals transaction fee. Ayo, is that correct? Yes, is it?
Yes, yes, yes.
Okay. We have Akim Fala. I like these questions coming up. What is the difference between a blockchain developer and a blockchain engineer? Where DevOps engineer stands. So, Ayo, you can take the difference between blockchain developer and blockchain engineer, and I'll answer the DevOps part of
Yes.
things.
So now, when it comes to blockchain, there are different aspects to it. You could be a blockchain developer in that people classify blockchain developers as those that write smart contracts. Now, there are different types of smart contracts on different chains, especially if they are not even EVM compatible chain. When you write just smart contracts, people refer you as a blockchain developer. But when you go further to, you know, thinking of the protocol layer itself, that is thinking of what encompasses the blockchain itself, going deep dive into that. When you start thinking of the P2P layer, the execution layer, at that particular point, the
Consensus
consensus
layer.
layer, you start thinking of yourself as the blockchain engineer. So that's literally the difference. Blockchain engineers go deeper. They build the client itself. So yeah.
Okay, so DevOps, where DevOps stands. So DevOps is a different thing entirely from blockchain developer, blockchain engineer. DevOps, Web 2, Web 3, or whatever, is actually developer operations, right? We know what that is. You spin up machines, you handle infrastructure, you do CI/CD monitoring on the back end of your enterprise software or whatever. But what we're talking about is node ops, right? So node ops is actually a DevOps guy who has a blockchain experience. Okay. My daily routine as a node ops engineer, I can literally spin up a blockchain network, not just one node, a blockchain network. I know how it works, right? You know how the blockchain actually works from the back end. You spin up the infrastructure, you then configure each of the nodes in that network. You don't just spin up any amount of nodes. There's a mathematics to it, right? So that's why we do all this learning to get us up to speed. I hope that answers your question. Uh, would I use EC2 on AWS to spin up a node for a blockchain transaction? Okay. You use EC2. EC2 is just a machine, right? You use EC2 to spin up a machine and then you configure that machine with a blockchain node, right? So there are different documentations around there. Some people use Docker to set up the node, some people use binaries, some people use Ansible if you are going to set up multiple nodes at the same time. Some people use Kubernetes to set up the node, but if you're using an EC2, maybe using the binary or Docker would, depending on the documentation, if it's public, some companies have private documentations, which would be an entirely different case when it comes to like configuring. So the second part of your question is talking about spin up a node for a blockchain transaction. You don't spin up nodes for a blockchain transactions. If you send any, if you do anything on the blockchain, like sending money from one of your testnet wallets, MetaMask, or another testnet wallet, you've done, that's a transaction. If you go to a Web3 website and you kind of like connect your wallet and you sign, I think the what's that thing called? You have to sign, right?
Yes, a
You have to
transaction.
sign.
You have to sign the
Yeah, yeah,
transaction.
yeah. Once you sign a transaction, that's a transaction. I think transactions are actually when you make an update to the blockchain, right? You get a transaction hash. That's when it becomes a transaction, right? The next one is, please, we need a special class for on writing smart contracts. Okay, 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 okay. We would look into that in the nearest future. We always have IO. IO can always come back if it's available. Larry Ada says, is the UI designed for blockchain written on Web 2 or Web 3? If it is written in Web 3, then where would you write it? I feel, I have a feeling it's not written. It's okay, okay. Do you want to take that Web3 JS, Connect Wallet, those things? Do you want to take this question?
Okay, said is the UI designed for blockchain written on Web3 or on Web2 or Web3? If it's written in Web3, then where would you write it? I have a feeling it's not written in smart contract. Okay, now here's the idea. When you talk about UI, you are talking about the user interface. That is, we are talking about the front end. And now there are different tools for visualizing. That's the front end. You could either use React, you use Vue, you use Angular. There are different tools to it. Now, smart contracts, as you all know from the previous class on smart contract, are code that are deployed to a particular chain. Now, to interact with this smart contract, if you have to create a UI, now there are what we call interaction tools that connect your front end, which you know, to the smart contract. Now we have, like Ukeme mentioned, we have Web3 JS, we have Etherscan. There are different tools that allows you to do this. So if you are a front-end developer, you write a normal front end. When you connect this front end to the functionalities of this smart contract, then it becomes a decentralized application because you are now interacting with the blockchain, the smart contract on the blockchain. So the Web 2 part, which is the UI, is still the same React, you know. just that you have to now use another tool plus the React knowledge you have to interact with this smart contract. And that's all.
Yes, Aya is 100% correct. So your UI is basically still Web 2. But I know some guys who are actually specializing in like they do UI UX, but it's basically for Web 3 blockchain because Web3 has some peculiar things, some little tweaks in terms of UI. Like for example, Connect Wallet. Connect Wallet is something that you will see in most Web3 or most dApps, right? Decentralized application, and you have to put that in your front end. I'm just giving you like an example. So the UI is still Web2. The front end also is also still Web2. React is a Web2 technology, but when it comes, like Ayo said, smart contract interaction, right? Connecting that your front end to your smart contract, you need those interaction tools like Ayo has said. I hope that answers it. I think we've come to the end of the questions and answers. If you still have any questions, please let us know. Any questions? All right. Thank you, everyone, for coming to today's session. I think that was the last question. Thank you so much, Ayo, for taking this class. It's been very insightful. Also, we have an assignment for this week. We like to give assignments so you can go home and practice what you've learned. Perform a pitch. This assignment might be a bit dicey, but let me just put it there. Give me a minute. Perform a P2P transaction on a testnet and analyze the transaction details on a blockchain explorer. I just noticed that if we is a new development, I don't know if you know that we can't get faucets for free anymore. Testnet,
Yes, yes. So it's based on which faucet you want to, or on what chain, on what test.
Ethereum,
So that's for Sepolia.
Ethereum.
Okay.
Yeah.
So I have some Sepolia. So anybody that probably needs that, I could, send some test Sepolias to address this and need. Okay,
Okay. Okay. I think you just send it
no
to me, so
problem.
I will do that within the
Okay, no problem.
community. All right, guys. Ayo is offering free Sepolia testnet tokens. Kingsley says, "What would be the day-to-day tax of a node ops?" Uh, I think I've posted this before somewhere. I've posted it before on the group, so I'm going to post that again in the community, WhatsApp community. Day-to-day works, but majorly you are spinning up blockchain networks, different networks. You are managing them, you are configuring them, you are also assisting external node operators to set up their own nodes, and you are doing CI/CD. You are also running cron jobs. You understand? But your major job is to set up a network, manage it, monitor it, and also help external node operators with their work. Um, I think that answers everything. And that will be all for today. You'll get your Sepolia testnet on the platform. All right. Thank you, everyone. Thank you. We've gone past our time.